Okay, this presentation is about ionic bonding. Now, let's just review quickly what ionic bonding is all about. It's the idea that a positive ion and a negative ion are attracted to each other. And so that resultant in attraction between the positive and negative creates a very strong bond called an ionic bond. The force that actually holds it together is an electrical attraction. That actually makes it so it's much stronger than a molecular compound in most circumstances. There are, of course, exceptions to the rule. So an ionic compound by definition is composed of positive and negative ions that are combined so that the number of positive and negative charges are equal. And notice, equal is underlined. That's very important that they are equal to each other. Without them being equal, there would not be any stability at all. So ionic bonds are very unique and actually have specific types of structures that you'll find them. Most of them are found as crystallines, meaning crystals, in nature, and they actually form repeating patterns of positive and negative ions. And they have a specific name. Instead of, for example, when we have two nonmetals bound to each other, we call it a molecule when they're bound to each other. For an ionic compound, we call it a formula unit. So the easiest way in order to show the idea of ionic bonding is through the use of dot notation. The same way that we did, the only difference is in that ionic bonding, it's a transfer of the electrons, a stealing of the electrons. So if you look down here at this example with calcium and chlorine, you can see that calcium here has 2 valence electrons, and each one of the chlorines has 7 valence electrons. So what ends up happening is the calcium loses its electrons to chlorine because it has such a high electronegativity, and therefore the calcium becomes a +2 charge, and each one of the chlorides become a negative charge. And so we have a +2, a -1, and a -1, which makes a -2, so we end up with an overall of a 0 net charge. Over here we can see aluminum has 3 valence electrons for each one, and what ends up happening is that it loses these 3 valence electrons. And we have to find the right ratio of aluminum to oxygen to make it so that it will work. This is the only possible formula for aluminum oxide. It doesn't exist in nature in any way, other shape, or form because of the charges. The charges need to balance out. So you can see that the formula is Al2O3, 2 aluminums for every 3 oxygens. The aluminum loses 3 electrons, so it becomes +3. And each one of the oxygens gains 2 electrons to become a -2. So when we add up all that charge, it's +6 altogether, and a -2 plus a -2 plus a -2 gives us a -6. So again, add up those charges and we get a net charge of 0. So the difference between molecular and ionic compounds, you're going to need to know this. This is important because there is significant differences between the two. So molecular compounds can be found as solid, liquid, or gas in nature. They typically have very low melting and boiling points, and that's because of their what's called low intermolecular forces, and we'll get into that further on down the road. And most molecular compounds are very poor conductors of electricity. They will not conduct electricity very easily. Ionic compounds, though, almost all of them, with the exception of a few, are solids. They have very high melting and boiling points, meaning that they have very high attraction to each other. They're great conductors of electricity, especially when they're in their aqueous, meaning dissolved in water, or even in a liquid state. They're extremely hard, but they're also brittle, and they typically fracture along planes. Now, the other important part is there's this thing called polyatomic ions. Now, when you hear the word poly, you should think of the word many. So when we're saying polyatomic ions, we're saying many atoms that form into an ion. And some of these are actually all covalently bound, but they have a charge like an ion. And so some of them I've written down here at the bottom of the screen. You can see the nitrate, here we have sulfate, and here we have phosphate. Okay. Now, you notice that they each have a charge, and the reason they have this charge is because they've gained an electron in order to become more stable and follow that most important rule, which is the octet rule, and to make sure that they have 8 valence electrons in their outermost energy level.